So this next question asks us to write it in slope-intercept. So we have to find the slope first. So we have 5 minus negative 3 over negative 2 minus 2. So we have 8 over negative 4. So our slope is negative 2. And then we can use either point and plug it into point slope. So y equals negative 3 minus 2, x minus 2. We can do some distributing. So negative 3 minus 2x plus 4. And simplify. So we have 1 minus 2x. So this next one we're asked to graph this inequality. So we have negative 3x plus 4y is greater than 12. Solve for x, or excuse me, solve for y. So 4y is greater than 12 plus 3x. Divide by 4. So we have y is greater than 3 plus 3/4 x. So let's see, we have 3, 1, 2, 3, 1, 2, 3, 4. Since it's just a greater than, we'll have a dashed line. And then we have to test a point, and we usually test 0, 0. So if we test 0, 0, negative 3 times 0 plus 4 times 0 is greater than 12. Is 0 greater than 12? No, so we will shade the other side that 0, 0 is not on. So this next one looks a little messy here. I don't think when I uploaded it, it looks like the spacing didn't turn out right. But I believe you have negative 1/2 x plus 1 when x is less than negative 2, and negative x squared when negative 2 is less than or equal to x. So what I'm noticing here is we have a line and a parabola that's flipped upside down. So if we make this xy table, so negative 1/2 x plus 1, negative 2, and we need values less, so negative 3 and negative 4. So if we plug in negative 2, negative 1/2 times negative 2 is 1, plus 1 is 2. Negative 1/2 times negative 3 would be 1.5, so plus 1 is 2.5. Negative 1/2 times negative 4 is 2, plus 1 is 3. And when we graph this, this would be with a open circle. So negative 2, 2, we have an open. Missed that one. Let's try again. There's our open. Negative 3, 2.5. Negative 4, 3. And that makes sense because our slope down 1 over 2. If we kept going, we'd end up at our y-intercept there. So now we have xy for our negative x squared. And this will start with negative 2, but we need values that are bigger. And this one's tricky because when we're plugging in negative 2, it's the opposite of negative 2 squared. So negative 2 squared is 4. The opposite is negative 4. The opposite of negative 1 squared is 1. The opposite is negative 1. And 0 squared, so that's 0. So negative 2, negative 4, and that's closed. And what I'm noticing is this doesn't look like a parabola, but I know it's just a parabola facing down, so I can start there and just keep on going. Now this next one I think got a little bit messed up, if I remember right. Yep, it didn't print. So let's see. 1, 2, 1, 2, 1, 2, 1, 2. So there's our f of x. And our g of x went down the origin and then down to 4. So it looks like it flipped and doubled. So it says here we have to write the transformations. Well, if it flipped, it's got to have a negative. And you can see that it doubled. So a height of 1, and now it's at 2. This original one here is 2, and now it's down at 4. So even though it says plus b, there was no right or left shift. So g of x would just be negative 2 f of x, because it flipped and the height doubled. Well, now it says draw this one, f of negative x minus 3. So it goes down 3, and then our x values are the opposite. So this coordinate here, negative 2 becomes 2, and then down 3, 1, 2, 3. Negative 1 becomes 1, and then down 3, 1, 2, 3. 0 would say 0, but down 3. And then this one, so 2 goes to negative 2 and down 3, 1, 2, 3. So you can see it flipped over the y-axis and then doubled. So this one is separate from the rest. We're asked to describe the transformations. So 2, so double y, plus 1 left 1, and up 5. So we're just describing the transformation there. This next one, what happens? Well, half of x minus 1, and we have to translate this coordinate. Well, minus 1, so to the right 1. Half of f, so that's half the y value. So if we look at our coordinate, to the right 1 would be 4, half the y would be 1. And then this last transformation, what happens? Well, minus 1 moves to the right 1, and our y values are doubled. So we could think of it as a stretch vertically. So these next couple here, odd, even, or neither in the end behavior. Well, end behavior, we don't need a calculator. Here's our highest power, and it's even and positive coefficient. So as x goes to infinity, y goes to infinity. Since they're both even, we know it's going to end going up. And then as x goes to negative infinity, it's also ending up. And then for odd, even, neither, we could graph it. So if we go to Desmos here, let's see, we got 4x to the power of 4 plus 2x squared minus 5. Well, if we graph it, it's reflection over the y-axis. So if we go back here, this one must be even. So our next one, we look at this highest power. It's odd, so it's that bendy straw, and it's negative. So it starts high and goes low. So as x goes to infinity, it's going, if we go over, it's going down. So y goes to negative infinity. And then as x goes to negative infinity, y is going up. So y goes to infinity. And then we can take a look at the graph quickly and see if it's odd, even, or neither. So let's graph this one quickly here. All right. Is it going to come back up? Here we go. All right. So let's see here. We have negative 5x to the power of 3 minus 3x plus 7. So if we graph this, let's zoom out and see what it looks like. It's definitely not even, and if we rotate it, it's not the same, so this one would be neither.